Hello everyone, my name is Bharti Patel, Assistant Professor, Computer Science and Engineering Department, Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today, let's do a quick recap of the key concepts we covered in our previous lecture on template matching for object detection. Template matching is a fundamental technique in computer vision used for object detection and localization. It involves comparing a small template image which represents the object of interest or ROI, region of interest, with regions of a larger target image. By sliding the template over the target image and calculating a similarity matrix at each position, we can identify areas where the template closely matches to the target. When the similarity score exceeds a predefined threshold, a match is detected. Template matching is a simple yet effective approach for detecting objects with distinct patterns, but it can be sensitive to changes in scale, rotation, lighting, and occlusion. While suitable for certain scenarios, more advanced methods like neural networks and deep learning have largely surpassed template matching in handling complex and variable object detection tasks. So let's begin with the detailed understanding of the today's lecture on Introduction to Deep Learning for Image Classification and Recognition. So deep learning, it is a revolutionary subset of machine learning, empowers us to unravel complex patterns and insights from data using neural networks with multiple layers. In this journey of understanding, we will explore the fundamental principles of deep learning using the versatile Python programming language. So, deep learning transcends traditional machine learning by empowering intricate neural networks. These networks, inspired by the human brain structures, adaptively learn patterns and features from the given dataset. Python, with its rich ecosystem, provides the ideal platform for exploring these technology. So, neural networks and layers are at the heart of deep learning are artificial neurons interconnected in layers. Python libraries such as TensorFlow and Keras facilitate the construction of neural networks. Each layer specializes in feature extraction, progressively uncovering complexities within the data. So, what is activation functions? Activation functions infuse neural networks with non-linearity, enabling them to capture intricate relationships within data. Python allows us to implement functions like ReLU, sigmoid, and 10-head to amplify network capabilities. So, what is forward and backward propagation? Python enables us to comprehend the mechanism of forward and backward propagation, the core of neural network training, by feeding data forward and adjusting weights backward. The network learns to make accurate predictions. So, what is loss functions? Python's intuitive syntax assists in implementing loss functions like mean squared error and cross entropy. These quantify the disparity between predictions and actual outcomes, guiding the network's learning process. So, what is optimizers? With Python, we integrate optimizers like stochastic gradient descent and ADAM to fine-tune neural network parameters iteratively. These optimizers ensure convergence towards optimal solutions. So, next topic is deep versus shallow networks. Python code aids in comparing deep networks with shallow counterparts. Deep networks unravel intricate features, enhancing performance and accuracy in tasks like image recognition and neural language processing, that is called NLP. So, next is convolutional neural network, that is called CNN, which is very common and which is going to be used very effectively nowadays. So, Python empowers the creation of convolutional neural networks CNN, a stalwart for image-related tasks, CNN automatically learn special hierarchies of features, revolutionizing image classification and recognition. So, what is CNN architecture and why it is very important to know? Because at the heart of a CNN lies a series of interconnected layers designed to extract and process features from images. These layers include convolutional layers for feature extraction, pooling layers for downsampling, and fully connected layers for classification. The architecture of a CNN is engineered to progressively uncover higher level features by applying transformations to the input data. So, first is convolutional layers. Convolutional layers are the backbone of CNNs designed to convolve filters, also known as kernels, over the input data. Each filter slides over the input, computing dot products and generating feature maps. So, these feature maps highlight specific features like edges or textures within the input images. So, Python libraries enable seamless integration of convolutional layers, allowing us to harness their power for image analysis. So, next one is filters and feature maps. Filters serves as the eyes of a CNN, extracting patterns, which is called features, from input data. These filters can detect edges, corners and textures at varying scales. As the filters slide across the input, they create feature maps that emphasize the presence of particular features. So, Python code facilitates the creation and application of filters, enabling CNN to autonomously identify and amplify salient features. So, this is the code. Here we can show that how to make a CNN architecture, simple generation of CNN architecture, which is in generalized form. First of all, we have to import the libraries, that is TensorFlow, which is very common, TensorFlow and Keras. Then define a simple CNN architecture. In this, we have to make the model with the sequential layer, then max pooling layer, activation function, that is ReLU, which already discussed in the previous courses, in the previous slide, and the max pooling having the 2D type of array for particular image with the specified dimension. So, we can add that pooling layers more than 3 or 2. So, here lots of pooling layers are there with the activation function, which is called ReLU. Then compile and train the model. We have to compile and we have to use optimizer as Adam. We can use another optimizer also. So, here we are using the generators and epochs, that is our iterations, which is defined here as 10, and we can calculate the accuracy. So, in summary, convolutional neural networks are a game changer in image analysis. Their innate ability to capture intricate spatial hierarchies of features allows them to excel in tasks like image classification, object detection and more. Through Python, we have the means to explore, design and deploy these powerful networks, shaping the future of computer vision. So, next one is pre-processing and data augmentation. Pre-processing and data augmentation is very important to improve the accuracy. So, we have to give a look about this. Pre-processing and data augmentation play a pivotal role in preparing image data for deep learning. These essential steps lay the foundation for training robust and accurate models. In this section, we will delve into the significance of effective pre-processing techniques like normalization and resizing, and the transformative power of data augmentation. So, Python libraries like TensorFlow and Keras provide the tools to seamlessly execute these processes. For this, we have to know what is the effective pre-processing method. Pre-processing involves a series of operations applied to raw image data to ensure uniformity and quality of that particular input image. Then one crucial step is normalization, where pixel values are scaled to a common range, it means 0 or 1 or 0 to 1, to stabilize learning and convergence during training. Additionally, resizing images to a consistent resolution ensures that all input data has the same dimensions, facilitating model training. So, this is the Python example for normalization and resizing. You have to implement this code. For this, first we have to import the library function, that is TensorFlow or Keras, for preprocessing the images. Then we have to create an image data generator for preprocessing, which is required to generate the number of pixels according to normalized pixel value. So, we have to define the normalized pixel values, then shift that image with some value, with some predefined values, then shift the images vertically. We can shift it horizontally also, but here we are using vertically. So, rotate the images with some degree, either it is defined as 30, we can rotate it up to 40 or 50. Then zoom in or zoom out. After zoom in, zoom out, we have to flip the images horizontally. So, apply pre-processing to the data set. For that we have to take that generator, train generator, and we have to define the target size, which is already predefined, and we have to classify the class mode, that is categorical class mode. So, next is data augmentation. Data augmentation is a powerful technique that artificially expands the data set by applying various transformations to the images. And why it is required? Because we need to expand the data. For deep learning, we have to include the huge amount of data for better accuracy. So, data augmentation is a kind of technique which provide the extension or expansion of the data. So, these transformations include random rotations, shifts, zooms and flips. Data augmentation helps the model generalize better by exposing it to a wider range of variations that is might encounter during real world scenarios. So, Python example for data augmentation is here. For that we have to import the libraries like TensorFlow and Keras. Then we have to create an image data generator with data augmentation values. In this code we can see that we are taking data generator for data augmentation. We are taking data generator, then we are using the rescale value, then the rotation range, then width shift range which is predefined, height shift range which is also predefined here, shear range, zoom range and horizontal flip value, that is true. So, we have to perform all these values with the particular task, and again the mode is nearest. So, after that apply data augmentation to the data set with these values, predefined values, and we have to define the target size and we have to define the batch size as well as class mode. In essence, preprocessing and data augmentation are indispensable steps that optimize the input data for deep learning models. Through Python and libraries like TensorFlow and Keras, we can seamlessly integrate these processes into our workflow, enhancing the model's ability to learn and generalize from diverse and representative data. So, these techniques empower us to achieve more accurate and robust results, ultimately evaluating the performance of our image classification and recognition tasks. So, next is building an image classifier in Python. We need some steps to build an image classifier by using Python. So, it requires that it involves a systematic process that encompasses data loading, model design, training and evaluation. So, Python libraries like TensorFlow and Keras provide a user-friendly environment for creating and training neural networks. By following a step-by-step approach, we can construct a powerful image classifier capable of categorizing images into predefined classes. So here is the code which is going to be used for building an image classifier. We need to import the libraries TensorFlow and Keras. After that, we have to define a simple CNN architecture. As we already discussed, we have to take all the values, activation functions, pooling layers, dense pooling layers with the activation function. That first we have to use the ReLU. Again we are using ReLU only. Then in the dense form we are using softmax. Then here we are assuming 10 classes. So compile and train the model. For that we are using optimizer Adam. We can change it also, and the loss value, that is categorical. Then matrix value, which is giving the accuracy. We are taking approaches, that is our iterations 10 and the train generator. So next one is transfer learning. Transfer learning offers a shortcut to building accurate models by leveraging predefined networks. By using a model pre-trained on a large dataset, we can fine-tune it for our specific tasks. Python libraries provide tools to load, modify and retrain these models, making the process efficient and effective. So some examples are there for transfer learning. One of the example is here. We can see in this example that first of all we are taking ResNet, that is kind of for transfer learning model. For that we have to import the library functions TensorFlow and Keras, and we have to load the pre-trained model, that is called ResNet 50. We are taking some other models are there. In this model we have to define the weights and we have to include all the values which are required to make our data for the implementation. So we can customize and retrain the model. We have predefined model, now we are going to customize it according to our need, or we can say we want to implement according to the data set. So for that we have to take the sequential values with the base model, then flatten it, then we have to take the dense layers with the activation function of ReLU, and we are taking here as 10 classes for the activation function of softmax. So compile and train the model, we need to include the optimizer, that is Adam, and we have to define that categorical value and the matrix values accuracy which are going to perform by this model. So model fit is required to provide the values or the iterations, 10 iterations we are going to take here to define that values. So what is deployment considerations? We can see like deploying a deep learning model involves considerations such as model optimization, compatibility and scalability. Python provides frameworks like TensorFlow serving and ONNX runtime for efficient model deployment. It is essential to choose the right development strategy based on your application's requirements. So requirements are like, first, future trends in deep learning. The field of deep learning is continually evolving, opening doors to exciting future trends. Some of these trends include, first, expandable AI, or we can say XAI, enhancing model interpretability and providing insights into decision making processes. Second one is generative adversarial networks, generating realistic data, arts and media. Third is reinforcement learning, which is very useful nowadays. It is highly used by the researchers, which is giving the teaching models to make decisions through trial and error. And the fourth one is automated machine learning, AutoML we can say, that is giving streamlining the model development processes. And the fifth one is federated learning, or we can say collaborative training of model across distributed devices. And another one is ethical AI, that is giving the ensuring responsible and unbiased AI deployment. So Python's adaptability and rich ecosystem position it at the forefront of these emerging trends, empowering developers to lead the way in shaping the future of deep learning applications. With these concepts in mind, you are well equipped with navigate the process of building image classifiers, harnessing transfer learning, considering deployment strategies, and anticipating the exciting future of deep learning advancements. So what is image classification and recognition? Image classification and recognition are pivotal tasks in computer vision, enabling machines to comprehend and interpret visual data. Let's dwell into the intricacies of these tasks. Their distinctions are how deep learning techniques coupled with Python have evaluated their accuracy and efficiency. So image classification basically gives that revolvement of around assigning a label or category to an entire image. It is like sorting images into distinct folder based on their content. For instance, classifying images of animals into categories like cat, dog and horse. So Python armed with libraries like TensorFlow and Keras streamlines the process by providing tools to load data, design neural network architectures and execute the training process. So this is a simple example for image classification. We can see that we are importing the library files, then loading the pre-processed data, then build and train a deep neural network with the value which are assigned here with the optimizer and the loss function and the matrix value. So it is all about the image classification. Then next one is image recognition. Image recognition takes a step further by not only categorizing the image but also identifying specific objects or patterns within it. It is like recognizing the exact breed of a dog in an image. It is one of the example for this particular topic. So deep learning techniques excel in this task, dissecting complex features through convolutional layers and pooling, effectively capturing hierarchical patterns in the data. So this is a simple example for this image recognition. We have to take the libraries file, then we have to load the pre-trained model which is ResNet 50. Then we have to load and pre-process images for that image recognition. For that, in this code we can see we are deciding the image path, then with the target size which is predefined. Then we have to convert image to array and then pre-process that input value which are in the form of arrays. So predict the object in the image and then identify the, or we can say the recognize the class name, that image belongs to which class. So in summary, image classification assigns labels to images while image recognition identifies specific objects. Python along with deep learning frameworks empowers us to seamlessly accomplish these tasks, advancing accuracy and performance to new heights. The synergy of deep learning and Python enables machines to perceive, understand and interact with visual data, transforming the landscape of computer vision. In conclusion, our journey through the introduction to deep learning for image classification and recognition using Python has unveiled the remarkable potential of these transformative technology. We have explored fundamental concepts divided into convolutional neural networks which is called CNN and learned about pre-processing, data augmentation, transfer learning and deployment considerations. So as we wrap up, let's reflect on the outcomes and key takeaway from these exploration. So first one is foundational understanding. We have gained a solid foundation in the core concepts of deep learning, including artificial neurons, activation functions, layers, filters and loss functions. These understanding forms the bedrock for constructing and training powerful neural networks. Next is convolutional neural networks. We have uncovered the significance of CNN in image related tasks, understanding their architecture, convolutional layers, filters and feature maps. These networks empower us to excel in image classification and recognition tasks with remarkable accuracy. So next is effective preprocessing and data augmentation. We have witnessed the importance of preprocessing techniques like normalization and resizing along with the transformative impact of data augmentation. So these steps optimize data for training, enhancing model performance and generalization. Next is transfer learning. We'll see further also what is the basic models for transfer learning and some of the basic architectures. So here we have harnessed the power of transfer learning, leveraging pre-trained models to expedite the development of accurate image classifiers. This technique offers an efficient approach to building robust models for specific tasks. Development consideration. We have explored development strategies and considerations, ensuring that the models we create can be effectively deployed in real-world applications using frameworks like TensorFlow, serving ONNX runtime. Future trends. We have glimpsed into the exciting future of deep learning with trends like explainable AI, GAN, reinforcement learning, and ethical AI shaping the landscape. So Python's adaptability positions us to embrace and contribute to these evolving frontiers. As we conclude, remember that the knowledge gained from this introduction serves as a stepping stone. Armed with Python's capabilities and a deeper understanding of deep learning, you are equipped to embark on a diverse range of projects, solve complex image related challenges, and contribute to the rapid advancements in artificial intelligence and computer vision. Embrace the endless possibilities that deep learning presents and continue your journey towards mastery and innovation. Thank you. Anticipating our next encounter, whether in the next video or whenever assistance is required, brings a sense of excitement. Wishing you a wonderful day ahead and looking forward to our future interactions. Until then, take care and goodbye.